Welcome to my YouTube channel. So today we are going to answer a question on travel graph, which reads, the diagram below shows the speed time graph of a moving object. Then here now we have speed and here we have what, time. And now the question is saying calculate what, acceleration of the object when time is what, 3, when t is 3. So since they have mentioned the acceleration, so you use the formula for acceleration, which is a is equals to v minus u over what, t. So the v you are seeing here is the final velocity. The u you are seeing here is the initial. Then t is what, time taken. So now since we are calculating acceleration, so acceleration, you focus where you have a slope which is going up on your right. It had to start from here up to here. So meaning final, since it had to start from here, then end here. So final is what? Here. So final velocity you get what? 24. So where there is v here, you put what? 24. Minus u is initial is here, which is the 4, over time. Time now, time check now. So time on the question, time is saying 3, yeah? Then here now on the diagram, initial is 4, then final is what? 24. So meaning time here is what? 5. So meaning that's the time you use. You use what? 5. The reason why you use 5 instead of what? 3, because the question is saying calculate acceleration when time is what? 3. So you can assume that 3 is between 0 and what? 5 here. So now since we are calculating acceleration, or since we want to calculate acceleration, so meaning you move straight and hit this part and come this side. Now here there is no number. So since the question is saying calculate acceleration from here up to here, where there is no number. So since there is no number here, instead of stressing to calculate what, the number which is here, then you proceed to calculate what, acceleration here, so that you should use 3. You can just use the property which state that acceleration here is the same. Since acceleration here is the same, so meaning the acceleration you calculate from here up to here will also be the same acceleration from here up to what, here. So I'll use this because we have 1 mark here. It's 1 mark here. So meaning we'll say acceleration from what, 4 to 24. Time taken is what, 5. Now I'm using 5. Contrary to the 3 which they are saying. If you want to use 3, meaning you have to find what? You have to find what? Speed here at what? 3. That's when you can use 3. Which I can show you if you inbox me. But for now, let us just go straight forward because we all know that acceleration here is the same. Since acceleration here is the same, so I'll use this point and this point here because I have numbers here, numbers here, numbers here, numbers here, which is simple. So 24 minus 4 is what? 20 over 5. Then 5 into 20 you have what? 4. Then now it's acceleration. Then the units for acceleration is meter per second squared. So that's the answer for the first one. The next one now is saying, given that the object decelerates at 2 meters per second squared. The key word there is decelerate. So when you hear decelerate, just know that it's the opposite of what? Acceleration. When we say it's the opposite of acceleration, acceleration is the increase of what? Velocity with respect to time. Meaning deceleration now will be decrease of velocity with respect to what? Time. So deceleration is the decrease of velocity or speed. Now the same deceleration, at times they can use what? Retardation. They can use retardation. So we use the formula for acceleration. Acceleration is equals to v minus u over t. Yes, the reason why we are using the formula for acceleration instead of what? Deceleration, because we said deceleration is the opposite of what? Acceleration. Since here on the question we have been given what? Deceleration. We have been given deceleration. The deceleration we have here is what? 2 meters per second squared. So since we have deceleration, and here we have acceleration. So meaning the opposite of 2 will be negative, since we are using this formula. So where there is a here, you put what? Negative 2. I'll say it again. Every time when you calculate deceleration, you use the formula for acceleration, you have what? Negative. Since here we have deceleration and it's positive, when you want to put it where there is acceleration, it will be what? Negative. So deceleration there is positive. You are putting here where there is acceleration, which is supposed to be positive. Now it's deceleration, so you put what? Negative. Deceleration is the opposite slope. Since here we said initial is here, final is here. So now here it will be initial here, final here. We are focusing on this slope here. So now final, we are moving from here up to here. Don't get t. T is for time. Final velocity meaning will be what? 0. Meaning it had to reduce from here up to here. So this is the final. So final, you get it from here, 0. So where there is v here, you put 0 minus u. U is here, initial, which is what? 24. Over t. T now will be time taken here, time taken. You can't say what? T, no. Imagine if you had 13 here. If you had 13 here and you need time here, you say 13 minus what? 10, which is 3. Now there is a letter here, t. So meaning you say t minus what? 10. T minus 10. Because we need the interval here. We get the interval here. You can't get t, no. So here you say 0 minus 24, you have what? 0 minus 24, negative 24, over t minus 10. This is a fraction. So this in fraction form you say over 1. Whenever you have equals between fractions, you cross multiply. Negative 2 times t, negative 2t equals, negative 2 times t, you have negative 2t. Again, negative 2 times what? Negative 10, positive 20 equals 1 times negative 24, negative 24. What we are interested in is what? T. Like terms, this it has no letter, this has no letter. So this will follow the other there. So here we have negative 24. This is positive. When it crosses, becomes what? Negative. Then here we have negative 2t equals negative 24 minus 20. You have negative 44. So we need t. So you say over negative 2. Over negative 2. This and this will go. You have t is equals to negative, here negative 2 into negative 44. The negative and the negative will go. So 2 into 44, 22. It's time, and we have units here, second. So this is your answer. The last one. Calculate the average speed of the object in the first 10 seconds. Calculate the average speed of the object in the first 10 seconds of the journey. So we are calculating average speed. In the formula for average speed, you say average speed is equals to total distance over time taken. We are calculating average speed. So now total distance, we don't have distance. So since we are calculating total distance in the first 10 seconds, so you use the time here, the line for time. We have 0 here, first 5 is here, meaning first 10 is here. So since the question is saying calculate what? Calculate average speed in the first 10 seconds. So meaning is from here, 0 up to what? 10. So meaning we use this shape here. That will be our distance. Then time will be what? 10. So now let us calculate what? Distance. So to calculate distance here, whenever you are dealing with the speed or velocity travel graph, whenever you are dealing with speed or velocity travel graph, if you need distance, the distance should be the area for that shape. So here, since this shape here is a shape which is like this, so now we don't have We don't have a name for this shape here. So meaning what you do now, since we need the area for this, so meaning you start cutting this area, this region here. You start cutting to the shapes which you are able to recognize. So now, if you check here, this is a what? Trapezium. And also here it's a what? It's a what? A rectangle. So meaning you calculate for this part here and this part here, then done. So let us start. So this is a trapezium. So a trapezium, the formula for area of a trapezium, you say area. Now we are saying area is the same as distance. So you say distance is equals to 1/2 open bracket a plus b close h. So now here you say 1/2 open bracket a and b should be the lines which are parallel in a what? Trapezium. So this line here is parallel to this. So these are your A, B. You can't get this and this because these are not parallel. These and this, they are not parallel. So meaning this is our A. This is our A. We are using vertical. So you get it from what? Speed. From 0 to 4. So A is what? 4. Plus B. B is this now. So since we are using vertical, so meaning you get what? 24. Then height. So height automatically will become this 5. So 4 plus 24, you have what? 28. Then here you can now divide after adding. So you can say 2 here, 1, here 1, here 2, 4. So we have 14 here. Then 5 times 4, 20. You write 0, you add what? 2. 5 times 1, 5, plus 2, 70. So keep a 70 here, keep a 70. That's the distance, just for this. If it was the distance in the first 5, then you end here at 70. Then now, since it's the distance in the first what? 10, up to here. So meaning we are done with this shape. The next now is this, which is a rectangle. So now, for the rectangle, use the formula for area of a rectangle, which is the area is equals to LB. Now, since we are saying area is the same as distance, no, I'm putting distance here. So L will be this here. I can't get 10 because that will start from what? 5, ending at what? 10. So 10 minus 5, 5. Times B. B is this, 24. So 5 times 4, what do you have? 20. 0, you would what? 2. 5 times 2, 10. Plus the 2, 12. Then now you add 70 plus 120 equals to what? 190. So this is the distance. If the question was calculate the distance in the first 10, then you end here. But since it was average speed, so go back to the formula. So you say average speed is equals to total distance will be 190 over time now. Time, it was in the first what? 10. So 10 into 190, 19. Speed units is this. So this is the end of this question. So usually we'll be recording questions which seems to be a bit challenging. Those which are simple, yes, they come also, but I can easily teach you privately those questions which are simple.